Vector quantities and vector basics. Scalar quantities are so called because, in general, they are read from a scale. So we're talking about things like speed or length. And in fact, there's another one here on the speedometer. We've got temperature. Scalar quantities have a magnitude or size only. Vector quantities have both magnitude and direction. As an example, if this scale is showing 60, and let's say that this is in kilometers per hour, then the speed is 60 kilometers per hour. But if we add to that the direction, 60 kilometers per hour due north, that's then a vector. Examples are velocity, displacement, which is distance in a specified direction, weight, momentum, and of course there are many others. Vectors are represented by directed line segments. And what we mean by that is part of a line with an arrow on it. So we might call this one AB or P. So the vector may be referred to as AB, the vector that goes from A to B, or as P. When handwriting, this is underlined, not bold. This vector here we would call CD, or perhaps Q. The vector CD is parallel to AB. In other words, it goes in the same direction. If we bring in another vector, EF, this goes in the same direction, and it's exactly the same length. Let's call this one R. We can say that AB is equal to EF because it has the same magnitude and the same direction, whereas CD only had the same direction. Or we could write that P is equal to R. Now let's consider a vector that goes in completely the opposite direction. AB is the negative of BA. When we add vectors on a diagram, we place the tail of one vector on the tip of the other. What do I mean by that? Let's suppose we have this vector here, and we add another vector Q. This is the tip of the first vector, and we can tell that because the arrow goes this way, whereas this is the tail of the vector Q. The third side of that triangle is the vector P plus Q. If we wanted to do P take away Q, then we would start with P. Now we can see that Q goes in this direction, so negative Q would go in the opposite direction. And we're putting the tip of P onto the tail of negative Q. And then the third side is P minus Q. Note the direction of the arrow. If we do P and then negative Q following the arrows, the third side goes between the same 2 points. And that was the case up here as well. Follow the arrows, the third side goes between the same 2 points. Vectors can also be multiplied by a scalar. Remember, a scalar is just a number. So here's AB, and this is a vector that is twice the length, but note, in the same direction. And this is a vector half the length of AB, but in the same direction. We could have 2P, and add it to 3q. And then this side would be 2p plus 3q.